In the previous lesson, you learned about matter changing states from a solid to a liquid, melting, or from a liquid to a solid, freezing, and you learned how there's a specific measurable temperature for substances that identifies the temperature at which that change of state happens. We call it either the melting point or the freezing point, dependent on which change of state is happening, solid to liquid or liquid to solid. In this lesson, we're going to learn about another change of state, from a liquid to a gas or from a gas to a liquid. But this one is different. It's not one fixed temperature at which a liquid will turn to a gas or a gas to a liquid. However, there is a critical temperature at which something important happens. We call that temperature either the boiling point or the condensing point of matter, and we're going to learn what that point is and how it's different from melting and freezing, which always happen at a very specific temperature. Now, in order to understand this, we have to go back once again to the kinetic theory of matter, which says that the particles of all matter are always moving all the time, dependent on the state and the temperature of matter. We learned that the particles of liquids are sliding past one another, and previously we learned that the particles of gases move around freely. This picture shows water particles sliding past one another because they are at a temperature that is beyond the melting point of matter. So these particles are not going to exist as a solid, as ice. Now notice that this temperature is still fairly close to the freezing point, so these particles aren't moving very fast. But something important happens with liquid particles as they are sliding past one another. Every once in a while, a particle that is sliding around is going to gain enough energy to freely move away from the liquid and become a gas. We call that evaporation. And particles will just spontaneously escape by gaining enough energy to do so and evaporate away from a liquid. You don't even have to raise it to a critical temperature, and a substance will just eventually evaporate away. You've probably noticed that if you've ever spilled a puddle of water on the floor, you don't have to boil that puddle of water, and it will just over time slowly disappear as the particles spontaneously gain enough energy to escape and become water vapor. Now, what happens when you heat this liquid water up? As I raise it to a higher temperature, notice that the particles are moving much more quickly, they have much more energy, and it's much easier for these particles to spontaneously gain enough energy to escape the liquid mass of water and become a gas, moving freely around. This liquid water hasn't yet been raised to its boiling point, yet it still is able to evaporate. What's so special about the boiling point? Well, here it is. The boiling point of a substance is the temperature at which that substance can no longer be a liquid. The liquid substance will remain at that temperature, and particles that get heated above that temperature are going to escape the liquid as a gas until the liquid is entirely gone and has entirely turned into its gas form. That's the boiling point. Now, it's important to mention that the boiling point is a lot more changeable for a substance than the freezing melting point was. You can affect the boiling point of a substance by changing the pressure around the substance. For example, at a power plant, water is pressurized so it gets heated to an extremely high temperature, hundreds of degrees Celsius, yet it remains a liquid because there's nowhere for the particles to expand. They're all under extreme pressure and they can't become a gas. Because gases are confined to their container, you can do a lot more with the pressure on a substance than you can with the pressure on a liquid to keep it a solid. So the boiling point is very affected by the pressure on a substance. However, as physical science students, for now, we're just going to consider boiling something as if you're boiling it in an open pot on a stove. We're going to consider just regular conditions with regular pressure acting on the substance. I suppose you could also consider the condensing point of a substance as the temperature at which the gas substance becomes a liquid. However, you rarely ever hear scientists talk about condensing point. Oftentimes, they just refer to the boiling point of a substance, the temperature at which the liquid substance can no longer remain a liquid because it's gained too much energy to do so. So what does boiling look like? Well, at the atomic level, here's what the particles do when a substance boils. This is a picture of liquid water that has been heated to 100 degrees Celsius, the temperature at which the water boils. Now, if you could see these particles in motion, you would notice that the particles of liquid are sliding past each other at an extremely fast rate. But here's the interesting thing. We form pockets in the water of water vapor, of water that has turned into a gas. These pockets appear as bubbles in the boiling water, and those bubbles are just water vapor that is moving so quickly that it's pushing the liquid water away from itself and making a space in which the gas water is moving around. If you could see the particles of the gas, you'd see that they're moving extremely quickly. And that's what the bubbles in a boiling substance are, pockets of the gas of that substance. Now, here's what's interesting. The liquid water around these pockets can't get to above 100 degrees. If it raises above 100 degrees, it actually becomes gas. It forms these pockets, these bubbles. And that's what's happening when you see boiling water bubble up. The water is changing from a liquid to a gas at a very rapid rate. Here's the other important thing for you to note. The steam that's formed, that's the gas-water phase, can be much higher in temperature than just 100 degrees. Once water turns into a gas, you can continue then to raise its temperature up. But the liquid water won't stay a liquid beyond 100 degrees under standard conditions. So that's what boiling is. Boiling occurs when a substance reaches the temperature at which it can no longer be a liquid, and then it rapidly turns into a gas. And usually as that happens, you can see bubbles of gas of that substance forming in the liquid and then quickly raising to the top and bubbling out of it. The boiling point of a liquid substance is another fairly constant value that you can measure as long as you're measuring it at a standard pressure. Just like at the standard atmospheric regular pressure, the boiling point of water is 100 degrees Celsius.